The next section of the brain I will focus on is the limbic system. The limbic system is, uh, the word means border. And so this limbic system, which is actually a number of systems within it, is the border between the old brain and the new brain. So the limbic system is linked to emotion, fear, aggression, and to basic motives such as sex and hunger, food. So we have these specific parts inside the limbic system. You have the amygdala, the hypothalamus, the pituitary gland, and the hippocampus. So the amygdala are two almond-shaped neural clusters which influence fear and aggression and pleasure. Uh, what happened again with one of these experiments is they took some monkeys that were highly aggressive and they did some lesions in the amygdala, and these aggressive monkeys actually became very docile. And then they took some docile monkeys and they prodded the amygdala on the docile monkeys, and they became very aggressive. Let me spell the word amygdala for you. I know it's in your book, but it's Maygdal. It's an unusual word. So they have this link about this amygdala being related to fear and aggression and pleasure. And it is kind of interesting that they took some pedophiles, some men that have been castrated, and after castration, their amygdalas decreased by 30%, which is quite fascinating. And they certainly weren't as aggressive anymore. There's also a belief that the amygdala plays a big part in binge drinking and alcohol. The male amygdala is larger than the females, according to research, and perhaps can there might be a reason why men are much more visually stimulated than women. So when we think of the amygdala, uh, we really do think of fear and aggression when we think of the amygdala. Another part of that limbic system, which is so important in the emotions, is the hypothalamus. Now, the word hypo, that part of a word would be below, like hypothermia, hypodermic, below. So the hypothalamus is just below the thalamus and is about the size of a pearl. This hypothalamus is incredibly important to body maintenance. It's responsible for those autonomic functions of the peripheral nervous system, such as regulating thirst, body temperature, and sexual behavior. It monitors your blood chemistry and takes orders from your brain. It's what keeps that body in homeostasis, which is that balance. So it's kind of interesting. If you actually think about sex in your cerebral cortex, it will literally stimulate your hypothalamus to secrete hormones, which in turn triggers your pituitary gland, your master gland, to influence hormones released by other glands. This interplay between the neurons and that endocrine system. There is a part of that hypothalamus that is, it's considered a reward center. again, here we go with the animals. Um, this hypothalamus, which is, related, linked with emotion and reward. So they prodded the hypothalamus of some rats, and those rats would do anything to repeat the pleasure they felt when their hypothalamus was stimulated. They would practically just put themselves into a coma with wanting to be stimulated that much. Let's not even go there. But what it does is when that hypothalamus is stimulated, it releases dopamine, which we refer to as our pleasure pathway. Um, we don't go as far as the rats with the stimulation, but we do believe that a deficiency in this pleasure centered area can lead to addictive disorders. You're looking for something to replace that deficiency in those dopamine levels. So, dopamine is about reward, and low dopamine levels may create addictions for stimulants such as cocaine. It also has been stated that extroverted people have higher levels of dopamine, which would certainly explain a lot. So that's very interesting. So the wrinkled part of your brain that we all can visualize, that is actually your cerebral cortex. You flatten that and it looks like a pizza. It has the fissures and the cavities, and so much of that is what we are about. This cerebral cortex has a left and a right hemisphere, and that cortex is filled with those axons connecting the brain to its other regions. Believe it or not, I always say believe it or not when I give these statistical figures, because it's just, you can't even fathom it. That cerebral cortex contains some 20 to 23 billion nerve cells and 300 trillion synaptic connections. So that's quite amazing in itself. We don't really think about our brain, and when you hear information like that, you're like, I really should wear a helmet. So each of our hemispheres, you've got your right and your left, are divided into 4 lobes. At the front, you got your frontal lobe, your parietal lobe, the top and to the rear, the occipital lobe, back of the head. That's responsible for your vision. You've ever heard that expression? They've got eyes in the back of their head. And above your ears are your temporal lobes. So you have a lot of things going on, a lot of functions going in those areas. We're not going to dwell on too much of that because this is an intro class, but believe me, it has so many functions. The motor cortex goes from ear to ear, and that's incredibly important. And half of the motor cortex is devoted to movement of the face. And as I said previously, that those muscles in your face, so much of it is devoted to that. So your motor cortex sends out the messages to the brain, and then the sensory cortex, which is in the front of the parietal lobes, sends out more messages. The brain has, and you want to remember this, the brain has no sensory receptors, and that is why a person can be operated on. You can operate on a person's brain while they are wide awake. So they are not going to feel a thing. So you can be operated on and they can touch certain areas, and you might say you feel like you're being touched on your shoulder, and that gives them information that's very vital to your surgery. So it's incredibly important. We've got your auditory cortex, your visual cortex. and your travel goes around in a circle. You can actually stimulate an area while you're being operated on, and you might hear a sound. But out of your cerebral cortex, okay, we are actually only using a small portion. Now, you probably have heard that expression, oh, we only use 10% of our brains. Well, that is not true, but a small area of your brain is just devoted to your cerebral cortex, but 3/4 of that area is uncommitted to sensory or motor activity. So what's going on in that 3/4 of your brain? Those areas are actually called the association areas. And that's where those neurons integrate all the information, and it's not neatly mapped like the other areas. They're not dormant. They interpret, integrate, and act on information processed by those sensory areas. So much of the brain is uncommitted, but it is definitely not sitting idle. It's doing a lot of things. So, uh, you know, one thing about our brain is it can be damaged and other areas will take over. Read the section in your book about Phineas Gage. It will also come up in the next video that you're going to see, where he had damage to his temporal lobes, his prefrontal cortex, and it changed his personality. Certain areas of your brain do different things, and you can have damage to it. You can have traumatic brain injury, and every person is very different in what damage will be done. We can regenerate cells, very much so, but I have to say that damage to your brain, that plasticity of your brain where one area takes over another, it works best with children when you are young. We have areas of our brain that are related to language, and so many areas of our brain are related to language. We have a word called aphasia, and that is an impaired use of language, but it could happen to one of several cortical areas. You might be able to speak but not read. You might be able to read but not write. We have one area called Broca's. If it's damaged, a person would struggle to read words but could sing familiar songs and comprehend speech. Damage to an area called Wernicke's area. People could speak only meaningless words. It also disrupts understanding. And damage to another area called angular gyrus means a person is able to speak and understand, but they cannot read. So these nerve fibers connect all these areas. So, this damage, it works, that plasticity works better when you are young. Honestly, if you're young, you could lose an entire hemisphere and the other side of your brain would take on the chores, and other areas might be enhanced. So if you're blind, your touch might be enhanced. We can regenerate these new brain cells. That's that neurogenesis, and these baby neurons form deep in your brain, and then they migrate to areas where they're needed. We have the divided brain. We have an area of a brain that's called the corpus callosum. It's a wide band of axon fibers. It's connecting the two hemispheres. Okay, incredibly, incredibly important, sending those messages back and forth. Well, there was this gentleman who had such severe epilepsy that he couldn't even function. He could not function. And they felt that if they could sever that corpus callosum, that they might stop these incredible seizures that this gentleman had. But they were like, well, it could be that you will be totally impaired. And so, do you really want to take this risk? And he did, because he said, I just don't have the quality of life. So what they did is they, because he had so much excessive seizures during this part of the brain, they clipped the corpus callosum, and believe it or not, the seizures were eliminated, and the patient seemed relatively normal. It was really quite amazing. It showed different functions that the different hemispheres were now performing after no longer having that wide band of axon fibers going from one side of the hemisphere to the other side of the hemisphere. So that was really, really incredibly important. So the brain can grow, it can change. Some nerve cells, when they're gone, but we certainly can create new ones. And it goes without saying that we want to really protect our brain, because without it, we really are nothing. And it is incredibly important to every conversation we have from here on out in this chapter. And this is the last lecture on this chapter, and I'm going to have you watch a video, and then again you will take a quiz. Thank you.